Okay, welcome to my video. I am Nimai Das Bairagya, Assistant Professor in Agriculture Engineering Department, Haldia Institute of Technology. So today we discuss about the topic vapor absorption refrigeration system. So come to the slide. At first introduction. So vapor absorption refrigeration system. The concept of vapor absorption is first discovered by Michael Faraday in the year 1824. Later on, in the year 1860, a French scientist, Ferdinand Carré, he was developed the vapor absorption refrigeration system mechanism. So where he used the ammonia as a refrigerant and water as a absorber. So this is different from the vapor compression refrigeration system, because in the vapor compression refrigeration system we used the compressor, but here we can use a generator and a pump. So this is the basic difference between the vapor compression refrigeration system and the vapor absorption refrigeration system. So what is vapor absorption refrigeration system? So vapor absorption refrigeration system is where thermal energy is used rather than the mechanical energy, and a absorber pair, refrigerant absorber pair is used, commonly ammonia and water, and we can also use that the water and lithium bromide. In the vapor compression system we use that R22 refrigerant or R32 refrigerant, but here we used the water or ammonia water solution or water lithium bromide solution, that is non-toxic and also the environment friendly. So this system is also known as the eco-friendly. So here we also use a generator for generating purpose or generating the refrigerant gas. Again we use a generator instead of compressor. So come to the next slide. Working principle. So here basically 5 working principle we can observe. At first, evaporation. So evaporation and work is done in the evaporator. So what happened there? So in the evaporator, at the surrounding of the evaporator absorb the heat, and the refrigerant, liquid refrigerant turn into the gas. So here a phase change is happened from liquid to gas of the refrigerant. So yeah, and the evaporation is also happened here. So this is the working principle of evaporator. That is the principle of evaporation. Next is absorption. So absorption is happened in the absorber. So yeah, what happened in absorber? In the absorber, the gas of the or refrigerant gas from the evaporator, it come to the absorber, where it absorbed by water solution, and the weak solution is turned into the strong solution, that is ammonia water solution. Next, the generation purpose. So generation purpose is happened in the generator, where now we use a external heat source to boil the solution, the strong ammonia water solution, and we know that the boiling point of ammonia is very low than the water, as that's why it's turned into vapor in the generator. Next, the condensation. So condensation is happened in the condenser. So what happened there? Here also a phase change is done here. So from the generator, the refrigerant gas is come to the condenser. So condenser, it reject the heat from the um, refrigerant, and it turns into the liquid. So again it turn into the liquid refrigerant. Next, expansion. So expansion valve is here used. So for the expansion purpose, so when we open the expansion valve, is by the sudden opening of this expansion valve, the high pressure liquid refrigerant is turned into the low pressure chill liquid. So this is the basic working principle of the expansion valve. So come to the next slide. So here is the component uses in the vapor absorption refrigeration system. At first, mechanical pump, next absorber, generator, pressure reducing valve, condenser, a receiver tank for receiving the refrigerant, liquid refrigerant, and a expansion valve, and a evaporator where the refrigeration effect we can observe at the surrounding of the evaporator. So here is the diagram of the uh, system diagram of the vapor absorption refrigeration system. So we can observe that in the evaporator, the liquid refrigerant when enters into the evaporator, it absorbs the heat from its surrounding and turn into the vapor. Then the vapor is come to the absorber where is water is present here. So this water absorb this ammonia or refrigerant gas and produce the ammonia water solution in the absorber, and it also rejects some heat. Then it come to the heat pump. By using this heat pump, by using this pump, it convey to the generator. So in the generator where we boil this ammonia water solution, this ammonia water solution here in the generator we can boil by using some external heat source. By using external heat source we boil this ammonia water solution, and we know that the boiling point of ammonia is far less than the water. So at first the all ammonia mm, uh, in the solution is turned into the vapor and come to the rectifier. So in the rectifier here also a analyzer is present here. So what is the working principle of analyzer? So analyzer is basically analyze the gas. If there is some water molecules is present in this gas, so it don't allow it. The analyzer only allow the ammonia vapor to forward direction. So the water vapor is turned into the backward direction and come to the generator, and further it come to the absorber. So when it's allow only the uh, why it's allow the ammonia vapor only to the condenser? Because if water molecule also come to the condenser, the efficiency of this system is decreases. That's why water molecules is go back to the generator and further to the absorber, and the analyzer only allow the ammonia vapor. So in the condenser, when the ammonia vapor is come here, it reject heat, and uh, a phase change is done here, happened here, and the vapor of this refrigerant or ammonia vapor turned into the liquid ammonia. Then it convey to the expansion valve. So in the expansion valve, when the high pressure liquid ammonia is come to the inlet of this expansion valve, the sudden opening of this expansion valve, it turned into the low pressure chill liquid ammonia, or low pressure chill liquid refrigerant. Then it again come to the evaporator, where the evaporator, the liquid chill liquid refrigerant absorb the heat from its surrounding of the evaporator, and again it turns into vapor. uh, so this cycle is going on again and again, and the refrigeration effect is we can observe around this evaporator. So come to the next slide. So it is the mechanical pump to convey this ammonia water solution to the generator. Next, the absorber. So absorber is here to absorb this ammonia to the water. Next, generator. So now we see that generator, you can see this generator to boil the solution. We can use these types of generator. Next, a pressure reducing valve, we can use this to control the pressure. Next, condenser. So condenser we use here. So in the condenser, the refrigerant vapor refrigerant changes its phase and turns into the liquid refrigerant. Next, receiver tank. Before entering the expansion valve, a receiver tank also present there to receive the liquid refrigerant. Next, expansion valve. So expansion valve, we said previously that by suddenly opening this expansion valve, the high pressure liquid ammonia solution or liquid refrigerant turned into low pressure liquid chill solution. Next, evaporator. So we use the evaporator uh, here. Evaporator, we can see that by its surrounding, it absorbs the heat and turn into the liquid solution into the vapor. So it is the working principle of evaporator, and bring out the refrigeration effect which we have to need. So here is the diagram of energy source. So we can observe that here four energy source we can observe. At first, evaporator, we said that previously in evaporator it absorbs the heat, that's why these types of symbol we can denote it. The evaporator is absorb the heat. Next, absorber, absorbed is reject heat. Next, generator, generated, we said that previously external heat source is used to boil the solution in generator, that's why heat also absorbed in the generator. And condenser, we said that previously that it in the condenser the solution or sorry, the gas, the refrigerant gas reject heat, that's why the condenser reject heat to changes its phase from the vapor to liquid solution. So we can use refrigerant like when ammonia we can absorber as H2O. When use refrigerant as H2O, we can use LiVr, lithium bromide as absorber, and we can create the temperature minus 33.35 degrees Celsius, very low temperature. So this is the pair of refrigerant and absorber. If we use ammonia, we can use have to use water, and if we use water as refrigerant, we have to use lithium bromide. So these are pair. But previously we saw that in the vapor compression refrigeration system, here we can use single refrigerant like R22, R32, or many more. So coefficient of performance of this vapor absorption refrigeration system. So we all know that COP means desired by required. So what is desired here? That is refrigeration effect. We have the desire, that is refrigeration effect, and required work done. So in the diagram, refrigeration effect, that is QE, that is Q denoted by QE, and work done, mainly work done happen in the generator, that is QG, and also some mechanical work done also happen, that is WP. So but this WP is very less than QG, that mainly the work done happen in the generator, that's why we neglect this WP. So the COP in the vapor absorption refrigeration system is equal to QE by QG. So here are some advantage of this vapor absorption refrigeration system. At first, it is very energy efficiency, and waste of energy is very low. Next, this is the main vital point. This is very eco-friendly or environment friendly or sustainable to the environment. Because here we use ammonia water solution. This is not toxic anymore, so this is very eco-friendly. But in the vapor compression system, we use the very like toxic types of refrigerant, and it also produces the CFC types of chemical gas, which are the responsible for the global warming. But here we use the ammonia water solution, which is very eco-friendly. That's why this system is also known as the eco-friendly system, and the operation cost is also very low in the vapor absorption refrigeration system. And limitation, here also some limitation. So to run the system here, continuous a heat source, external heat source is required, because we said that previously to boil the solution, ammonia water solution, we use a external heat source, that's why a continuous heat source is required in the system, and large initial investment to establish this system. And next, efficiency is low for the small capacity system, but in the large capacity system the efficiency is quite good. And application, so this is various types of application of this vapor absorption refrigeration system. At first, the industrial application like chemical plant, breweries plant, or many types of processing plant, we can use this vapor absorption refrigeration system. We can also use this system in the solar cooling system. We can also use this vapor absorption refrigeration system as a air conditioning system in remote area where electricity is not present there, or electricity cost is very high. We can use this vapor absorption refrigeration system as air conditioning system, and we can also use as food storage or preservation purpose this vapor absorption refrigeration system. So these are the application of this vapor absorption refrigeration system. So thank you all to watching my video. Thank you.